Hello folks, we are taking the part 3 video for the exercise 3.4. We were finding the general solution. The sixth question is cos 3x plus cos x minus cos 2x equal to 0. If you are given an equation like that, you have to find the general solution for the x over here. So let's right away get across doing it. In the previous class, sometime I had told you that whenever you are having three trigonometric ratios with three measures, if they are in ascending order, generally club the smaller and the smallest and the biggest together. Generally the working works that way. So same thing we will do here. We've got the angles 3x, x and 2x. So common sense suggests that 3x and x can be clubbed together, apply the formula, get the answer. So maybe we'll do that way. So let's club cos x plus cos x together, cos 3x plus cos x together, apply the formula. Cos x plus cos y or cos a plus cos b is 2 cos a plus b by 2 cos a minus b by 2. So we are applying the formula and we'll get 2 times, given that it is 2 times cos a plus b by 2 cos a minus b by 2, and this cos 2x, of course we have kept it as it is, we'll deal with it later. So how does this work? This becomes 2 cos 4x by 2, so that's 2x, cos 2x by 2, that's x, minus cos 2x equal to 0. Both the cases cos 2x is common, so there's no harm in taking it out as common, cos 2x common, and in the bracket you have 2 cos x minus 1 equal to 0. Why we did this? Because here 2 cos x is left, here the entire cos 2x has come out, so only term that is remaining, there's no term remaining, so only 1 is remaining, and that's how you get it like this. Now, the product of cos 2x and this bracket is going to give you 0. So when a product is 0, either of the terms are 0. So that's how you're going to work out. So you can write here cos 2x could be 0 or 2 cos x minus 1 could be 0. Any one would be amounting to become 0. That's how the expression has become 0. Let's work it out. This is direct and we can apply this formula here. But this is not so direct. So let's see how you can work out. 2 cos x equal to 1. The 1 can go on the other side. 2 is multiplication, so it will go on the other side, it will become division. So what happens is, we will now work out from here. Cos 2x is 0, we'll apply this formula. That cos x equal to 0 means x is 2n plus 1 times pi by 2. So that means here 2x equal to 2n plus 1 times pi by 2. But 2x is not your interest is in x. So the 2 has to go on the other side. So it goes to the denominator and you get your x value as 2n plus 1, and since the 2 goes there, it becomes pi by 4. So this is your first general solution, that x is 2n plus 1 times pi by 4. Now let's see this. Cos x equal to half is in this category. See, cos x equal to half means cos x equal to cos pi by 3, cos 60, right? Half is cos pi by 3. Then we can apply our general solution, which says this way, that x equal to 2n pi plus or minus y. If this is the case, then the general solution will be 2n pi plus or minus y, which is pi by 3. What happens as a result of this? We have got both the general solutions. We have got the general solution 2n pi plus that's right, 2n pi plus or minus pi by 3. So let's write, thus x equal to 2n plus 1 times pi by 4 comma 2n pi plus or minus pi by 3 are the required general solutions. That's about this. Then we are moving to the next question, question number 7. So identical kind, sin 2x plus cos x equal to 0. We are supposed to find the value of x in a general form. We know that. What do we know? That sin 2x is 2 sin x cos x by formula. So instead of writing sin 2x, we are writing 2 sin x cos x. What is the advantage? Cos x is common, so you can take it out. Cos x is common. Let's take it out. What remains in the first? 2 sin x. No term in the next, so 1 is there, equal to 0, like before. One term and a bracket becoming 0, either of them can be 0, both can be 0, whatever. So we can write here, you could have cos x to be 0 or 2 sin x plus 1 to be 0. Now this is so direct. Cos x equal to 0, we already know that x is 2n plus 1 times pi by 2. So this we can write right away, that x is 2n plus 1 times pi by 2. But this we have to do a little bit of working. Sin x, 2 sin x will become equal to minus 1. So sin x will become equal to minus half. And where does sin become minus? Okay, minus half means it's minus sin. Half happens when it is 30. That means it happens at pi by 6. First time sin becomes negative in the third quadrant. So, and in the third quadrant, the angle is of the type pi plus theta. So, actually, therefore, sin x is actually equal to sin pi plus pi by 6. This is where it becomes minus. So, what happens when we equalize into 6 into 6? 6x plus 6 pi plus pi sin 7 pi by 6. So, you have come to this logic. Sin x equal to sin 7 pi by 6. So, what is the value of x that will happen? So, therefore, x will become equal to n pi plus minus 1 raised to n times 7 pi by 6. It's only that much. So, what happens? Thus, x equal to 2n plus 1 times pi by 2 and n pi plus minus 1 raised to n times 7 pi by 6 are the general solutions. This is how, very interestingly, we can find the general solution of the expression that is being given to us. That's about this. Remaining questions we'll be taking it up in the next part. Thank you.